In this video, you will learn about the different types of compute capabilities that are available on the IBM Bluemix platform. When you have finished watching this video, you should have a good understanding of the high-level features of each computing option. IBM Bluemix infrastructure server options, bare metal servers and virtual servers, IBM Bluemix container service support for Docker containers and container orchestration, Cloud Foundry application runtimes on Bluemix that you can use to quickly deploy a web application, mobile backend, or RESTful API endpoint, and OpenWhisk for implementing event-driven on-demand computing. Bluemix gives the developer a wide range of infrastructure as a service and platform as a service compute options. Bare metal servers give leading-edge cloud performance and full control of all aspects of the compute to the developer. Virtual servers and VMware increase efficiency and allow the developer to manage just the OS, middleware, data, applications, and VM operations like start and stop. Containers give maximum portability across environments. Developers create applications or microservices and package in a container, and then deploy to a service that could be on-premise or in the cloud. Cloud Foundry applications run apps using a supported runtime with explicit binding of managed services to applications. Developers push code artifacts to Cloud Foundry that are then packaged and executed with built-in support for horizontal app scalability. OpenWhisk provides a serverless platform to support functions as a service, where code snippets are run as a result of events. This gives a stateless model, where you pay for only the compute you consume. No application start or stop required. A bare metal server from Bluemix is just like a rack server from your IT department, except it's housed in your IBM Cloud data center of choice, located in one of over 40 locations worldwide. This allows you to place your compute and data close to your customers for maximum performance and address any necessary concerns over data locality. Speaking of maximum performance, bare metal servers allow you to optimize a configuration to your requirements. Both Intel and IBM Power 8 CPU-based systems are available in bare metal offerings. Like other Bluemix infrastructure server platforms, there is a three-tier network model that is provided, composed of management interfaces, private cloud interfaces allowing communication within and between IBM Cloud data centers, and public internet interfaces. Bare metal servers can be ordered in a number of configurations for CPU, memory, and storage. Compute-assisted GPU options are also available. Typically, applications with the most sensitivity to performance and capacity are matched with the bare metal server offering. This is the most powerful infrastructure as a service offering in IBM Cloud. A virtual machine is a software implementation of a machine that executes programs like a real machine. Within the virtual machine, or VM, is the application and a complete operating system running on virtualized hardware that is provided by a hypervisor. The hypervisor separates the virtual machine from the host and allocates resources as needed. Many VMs can run simultaneously on a single host system. The guest OS might not be the same as the server or host OS. Bluemix infrastructure uses VM technology to provide its virtual server offerings. Virtual servers can be made available in a much wider range of sizes and mix of CPU and memory configurations, since they are configured as software on the hypervisor. Like bare metal servers, each virtual server has three networks, one for management of the server, one for private networking within the cloud to your other servers, and one for public internet. You can choose whether or not to enable the public internet interface for each server. If you want just a group of private servers running the cloud and communicating with each other, that is an option. Additionally, Bluemix infrastructure has two hypervisor tenancy models that you can choose from for each server. You may select to have the virtual server be on a hypervisor with multiple tenants, and that's called the virtual server public or shared node option. Or you can request to have your services configured on a single tenant hypervisor, which is the virtual server private node option. In either case, you have full control of the server operating system, middleware, runtime, data, and application on each server based on the infrastructure as a service cloud model. In 2015, IBM introduced its cloud-based container service. It was one of the first wave of cloud as a service offerings supporting Docker containers. Containers enable you to build your app in any language with any programming tools. A container is created from an image, which is a read-only template that includes all dependencies and components that the application needs to run. Each container is an isolated and secure application platform separated from any other processes running on the host system. Applications in containers can run anywhere. Development workstations that are running OS X, Windows, or Linux, and servers that are running Ubuntu or many other Linux server platforms. Containers can help you build high-quality, portable apps quickly and without a lot of hard work. In the spring of 2017, IBM announced the availability of Kubernetes orchestration in the IBM Bluemix container service. Kubernetes provides an open platform for managing containers and deployments that combine simple scaling, rolling updates of container images, private container networking for services, and the ability to expose applications to the internet through a number of ingress and port services options. This slide shows the basic concepts of a Docker container lifecycle through the image building, image storage, and container run stages. Container images are built using a Docker file, a text document that contains all the commands or instructions to build the application image. These are read-only templates. The container build engine pulls the base image, here S, from the source image repository based on the instructions in the Docker file. It completes the other steps from the Docker file, including copying the application code into the container image. Completion of the build results in image in being stored local to the build engine. Container images are composed of a series of layers, each one corresponding to a change to the file system or other command. Loosely, you can think of an image corresponding to an element of the application stack. One layer for the operating system, another layer for tools and runtime, another for the application code, another layer for dependencies, and so on. Once built, the image is pushed to a registry, which serves as a container image repository for storage and sharing. This could be a public registry like Docker Hub, or an enterprise private registry. To create a running container, the Docker engine on the server or other hosting environment pulls the image from the container image repository. Then it creates a copy-on-write file system layer for use for the running application. All changes to this file system are ephemeral, and they're discarded when the container is destroyed. Cloud Foundry is an open platform as a service, providing choice of clouds, developer frameworks, and application services. Cloud Foundry makes it faster and easier to build, test, deploy, and scale application. It is an open source project and is available through a variety of private cloud distributions and public cloud instances. Cloud Foundry takes an open approach to platform as a service. Many competing platform as a service offerings place restrictions on developer choices of frameworks, available application services, and deployment clouds. The open and extensible nature of Cloud Foundry means developers will be not locked into a single framework, a single set of application services, or a single cloud. Using Cloud Foundry open source technology, Bluemix provides control where it's needed to application developers through this platform as a service offering. The goal is to simplify delivery of an application by providing services that are ready for immediate use and managed hosting capabilities to enable deployment at scale. With a broad set of services, runtimes, and APIs in Bluemix, the developer gains control and flexibility and has access to various technology, from Watson for cognitive, Internet of Things, and data science. Bluemix provides the following features: a range of services that enable you to build and extend web and mobile apps fast, processing power for you to deliver app changes continuously, fit-for-purpose programming models and services, manageability of services and application, optimized and elastic workloads, and continuous availability. In 2016, IBM announced the beta availability of OpenWhisk, which is an open source project to create a standard platform for serverless computing. This computing model is also called function as a service. IBM Bluemix OpenWhisk is a distributed event-driven compute service. It runs application logic in response to events or direct invocations from web or mobile apps over HTTP. Events can come from Bluemix services or outside sources. In this model, developers focus on writing only the application logic, creating actions that are executed on demand, and incurring charges only for active CPU usage. There's no need for explicit scaling steps like adding servers or instances, and no paying for hourly charges for servers when they sit idle. This concludes the overview of IBM Bluemix compute options. As you can see, IBM Bluemix has a compute offering to meet any cloud application requirement.